So this minus this is negative, but it's actually equal to negative 119 over 169. Okay, so now we know that sine of 2 theta is negative. We know that cosine of 2 theta is negative. So what's the only quadrant 2 theta could be in? Can't see my finger. Yeah, 3, exactly. It's got to be quadrant 3. That's the only quadrant where both sine and cosine are negative. So if you know the positive or negativeness of sine and cosine, you can always determine the quadrant that you're in. Okay. Sorry, I just covered up my stuff. Okay. Let's look at the next one. So you might notice if you look at this test, I didn't give quite as much detailed instruction, which will become maybe a little clearer when I get to problem 3C here. So the problem says, evaluate the following. You will need to use the angle sum formula as well as the half angle formula at least once each time, at least one time each, which I have not provided, but you're welcome to look up. So, but let's do the first ones. So secant of 5 pi over 3. That should be no problem. Right, we know the reference angle is pi over 3. We know that the quadrant is quadrant 4. And here's what I would probably do. I'd say, well, I know that secant of 5 pi over 3. I really don't know what secant of pi over 3 is. Like, I could pretend like I know it, but what I'm really doing is finding cosine and then flipping it. So that's what I'm actually doing. I'm saying this is 1 over cosine of 5 pi over 3. Because I know if my reference angle is pi over 3, that cosine is 1/2. And if it's in quadrant 4, it's going to be positive 1/2. So that's 1 over 1/2, which is just 2. You can show your work some other way. This is just how I think of it. So I feel like I wrote something slightly different in my notes here. No, I totally didn't. Wrote exactly that. Okay. Next one's, I think, a little bit easier, actually. Sine of 5 pi over 4? Yeah, 5 pi over 4. You don't usually see a lot of pi over 4s on my tests because I just feel like pi over 4 is the angle that's too easy. Maybe that's a fault of my own. But we know that the reference angle here is pi over 4. And 5 pi over 4 is, let's see, pi over 4 is in quadrant 1. 3 pi over 4 is in quadrant 2. 5 pi over 4 is in quadrant 3. So we're in quadrant 3. So we know it's going to be negative. And we know that for pi over 4, whether it's sine or cosine, we know that the answer is root 2 over 2, which is why I feel like it's sometimes too easy, because sine and cosine are both the same. That's it. Try and preserve this pen a little bit. Okay, the next one is cosine of 11 pi over 12. And seeing something pi over 12 should be an automatic clue that we have to use the angle sum or difference formula. So I'm first going to write this as a sum or difference. So I'm going to look for two fractions that add up to 11 pi over 12 and that both reduce. So that could be, there's actually two valid choices here. You could either do 2 pi over 12 plus 9 pi over 12, which is what I'll do here. Or in the solutions I wrote, you could do 3 pi over 12 plus 8 pi over 12. Both of them reduce. They're both valid ways of doing it. So this I can rewrite as cosine of 2 pi over 12 is pi over 6, and 9 pi over 12 is 3 pi over 4. And then we have to know the angle sum formula or look it up. So for cosine of alpha plus beta, it's equal to cosine of alpha times cosine of beta minus sine of alpha times sine of beta. So in this problem, pi over 6 is playing the role of alpha and 3 pi over 4 is playing the role of beta. So our thing is going to be equal to cosine of pi over 6 times cosine of 3 pi over 4 minus sine of pi over 6 times sine of 3 pi over 4. Cosine of pi over 6 is root 3 over 2. Cosine of 3 pi over 4, so that's in quadrant 2, so it's going to be negative, so it's going to be negative root 2 over 2. Minus sine of pi over 6 is 1/2, because cosine of pi over 6 is root 3 over 2. And sine of 3 pi over 4 is also a root 2 over 2, but it's positive, because again, we're in quadrant 2, and sine is positive in quadrant 2. Okay, now we simplify, and it always looks kind of the same. Root 3 over 2 times negative root 2 over 2. The roots multiply together, and you get root 3 times root 2 is root 6, but it's negative. Negative root 6 all over 2 times 2 is 4. Minus 1/2 times root 2 over 2 is just root 2 on top, because 1 times root 2 is root 2. And 2 times 2 is 4 on 1. And then you should always put these together in one fraction. And you should write this one as negative root 6 minus root 2 all over 4. Or if you prefer, you can factor out the negative and write it as negative root 6 plus root 2 all over 4. Just make sure that that negative is like way out in front of the fraction if you want to write it that way. Okay. So just like something pi over 12, right? This 11 pi over 12, just like that's a clue that we have to use the angle sum or angle difference formula. When you have a something pi over 8, that's a clue that you have to use the half angle formula. Or maybe clue is the wrong word, an indication. So let's see. Where am I? I'm looking over here. Sine of 3 pi over 8. So the half angle formula, which you may not remember, you can look it up. So for sine of theta, it's equal to plus or minus the square root of 1 minus cosine of 2 theta all over 2. The cosine formula is virtually the same, except it's a plus right here instead of a minus. So to find sine of 3 pi over 8, it's going to be plus or minus the square root of 1 minus cosine of 2 times 3 pi over 8 all over 2. And the first thing we have to do is actually decide, is it plus or is it minus? And it's wholly based on what quadrant this angle is and what trig function we have here. 3 pi over 8 is definitely in quadrant 1. And for in quadrant 1, all trig functions are positive. So it's got to be positive. But if this angle was in quadrant 3, for example, then we'd have to pick negative because sine is negative in quadrant 3. And the rest of this is mostly simplifying. So it's going to be positive square root of 1 minus cosine of 2 times 3 pi over 8 is 2 over 1 times 3 pi over 8, which is 6 pi over 8, or 3 pi over 4. It should always end up being a something pi over 4 right here, because it's double something pi over 8. Okay. Cosine of 3 pi over 4 is either positive or negative root 2 over 2, but it is negative because we're in quadrant 2. So this is going to be interesting. Just wondering, I wonder if I could I think this needs to be further over here. That might be better. Anyway, this is going to be, you don't need to write this plus sign every time. I'm just writing it to really emphasize it. 1 minus cosine of 3 pi over 4 is negative root 2 over 2. All over 2. Still all in the radical. This becomes plus. This is equal to 1 plus root 2 over 2 all over 2. And then that's where we multiply the insides of the radical by 2 over 2. So we get, so this 2 distributes to each of these terms. 2 times 1 is 2. 2 times radical 2 over 2 is just radical 2. And then 2 times 2 is 4. And then finally, the last step is that the square root of 4 is just 2. So it's no longer in the radical. And then the numerator part is still just all of that square root of 2 plus 2. So that's how this one simplifies. They always end up looking like this, except maybe it's a minus here and or a minus there. So it's always either positive or negative, and then it's root 2, positive or negative, root 2, all over 2. They always look exactly like this when it's a half-angle formula. Sorry, I'm just trying to think about ways I can orient my board. Hopefully this is very visible to everybody. I think that, yeah, I think it's better here. That way I'm not totally off camera when I stand on this side. I was gonna, I mean, I don't really need to be on camera, I guess, but I feel like it's weird to have this disembodied voice talking to you about math. I think it might be nice to see my face. Does that mean be like, so let me tell you things about math over here? No, I think this is better. Yeah, this seems better. Let's go to the next problem. Ooh, graphing. All right. Also, I will say I do intend to, if you do want to print things out, I will provide graphs that have and do not have grid lines, so you can pick whichever one you want to pick. I personally tend to prefer working without the grid lines, I think, just because it makes it easier to be a little more loose with my graph. But that said, if you like the grid lines, definitely use them. The first one, I want to graph y equal to negative 3 sine of 2x. I'll remind you that the usual graph of sine looks like this, right? Starts at the middle, and then goes top, and then middle, and then bottom, and then middle. But this one, since we have a negative out here, that's going to give us a vertical flip, meaning we're going to flip that over, and we're going to go middle, bottom, middle, top, middle. We also have an amplitude that's equal to 3. So instead of going up and down as much as 1, we're going to go up and down to a height of 3 and negative 3. We don't have a vertical shift. We will in the next one. And then the last thing we have to deal with is the period. And the period is going to be 2 pi divided by this coefficient of x, whatever that is. So in this case, the period is going to be pi. And then we need to find our 5 important x values. And since we haven't dealt with any that have a horizontal shift, our first x value is always just 0. Oh, I forgot one thing. Before we find the x values, we need to cut up our period into how many sections? Yeah, thank you. That many fingers again. Yes, 4 sections. So we need 1/4 of our period, which is real super straightforward, just 1/4 pi or pi over 4. So our x values, they're not intercepts, they're just our important x values. They're going to be first 0, and then we're going to add pi over 4 to get pi over 4. In fact, let me pi over 4. And then I'm going to add pi over 4 again to get the next one. And pi over 4 plus pi over 4 is 2 pi over 4. which yes, you could simplify to pi over 2, but you don't have to. And then we're going to add pi over 4 again to get 3 pi over 4. And finally, we add pi over 4 the last time, the fourth time, to get 4 pi over 4, which is just your period. And it makes sense, right? We've added 1 quadrant, 2 quadrants, 3 quadrants, 4 quadrants to get the whole period. Or 4 quarters, whatever. So then we graph it. So I'm going to mark off those 4 points and really just try to make them equally spaced. Each of these things should be equally distant from the next one. So if I make this first one like right there, then I'm trying to make the rest of them like that.
Do you want us to simplify them, or do you care like if we leave it like that?
You're welcome to if you want to. But yeah, I like to, especially like when I get to this one, I really don't want to simplify that one, at least in the beginning, because if I'm going to add pi over 4 to it again, I have to go back to 2 pi over 4, so I have a common denominator. But yes, you're welcome to write this as pi over 2, and this is just pi. So I'm doing sine. I know it's flipped vertically. And you can, as long as you have the x values down here, you don't have to also write them on your graph. You certainly can if you want to. So sine would usually, well, sine does start in the middle, and negative sine also starts in the middle. And then we, instead of going up to the top, we go down to the bottom. You could also plug in if you really wanted to check. Right? You could say, okay, I'm going to plug in pi over 4. 2 times pi over 4 is pi over 2. Sine of pi over 2 is equal to positive 1, but negative 3 times 1 is negative 3. So it does make sense that when we plug in pi over 4, we do in fact get negative 3 for our value. But you don't have to go that way. You can just remember what sine usually looks like and then flip it over. So middle, bottom. Once you're at the bottom, you have to go back to the middle. And then once you're at the middle, you have to go to where you weren't, which is the top. And then once you're at the top, you have to go back to the middle. So if you're at the top or the bottom, your next space is always the middle. If you're at the middle, you're always going to where you weren't before, whether it's sine or cosine. And then we try our best to draw a nice graph. One thing I'll mention that I saw a couple people doing, I think on the most recent homework assignment, is graphs don't just stop at the end of the period, right? I know, especially when I say graph 1 period, you can't stop them. But really, like, I would prefer you to draw these little arrows that kind of indicate things keep going. That's especially even more true for the polynomial graphs, right? Where polynomial graphs really don't stop at their x-intercepts. So make sure you're not drawing them that way. All right, and that's the whole graph. You can label, if you prefer, you can label the points instead of the x values. Either way is fine. But this is pretty well labeled if I have that there. Let's see, where's the next one? 2 cosine of 4x over 3 minus 1. Okay, so that's the graph we're looking at now, or the equation that we're going to graph. So again, we're going to talk about the usual stuff. An amplitude that's just 2. So meaning we're going to go up 2 and down 2 from whatever our middle is. But our middle is now going to be negative 1. Because we have a vertical shift of minus 1, which is down 1. So if I start graphing this, y equal to negative 1 is my new middle line. So I know cosine is going to start at the top, which is going to be 2 above. So we're going to be going as high as -1 plus 2, which is +1, and as low as -1 minus 2, which is -3. So we're always going as far above or below the middle line as whatever the value of the amplitude is. All right, the period is going to be 2 pi divided by our coefficient of x here is 4/3. So if you prefer, maybe you don't want to write 4x over 3, you could write this as 4/3 times x. That's also correct. And then be like, oh yeah, 4/3 is what I'm dividing by. Dividing by a fraction means you multiply by its reciprocal. This is the same as 2 pi times 3/4, which is 2 pi over 1 times 3/4. So I get 6 pi over 1 times 4 is 4, which reduces to 3 pi over 2. That's my period. And then 1/4 of my period is 1/4 times 3 pi over 2, which just becomes 1 times 3 pi on top, and 4 times 2 is 8 on the bottom. And it doesn't really reduce or anything, it just is what it is. So then our x values are going to be 0, and then we're going to add 3 pi over 8 to get 3 pi over 8. And then we're going to add 3 pi over 8 to get 6 pi over 8. And then we're going to add another 3 pi over 8 to get 9 pi over 8. Then we're going to add another 3 pi over 8 to get 12 pi over 8. And yes, of course, some of these reduce. 6 pi over 8 is 3 pi over 4. 12 pi over 8 is 3 pi over 2. And if you're starting at 0, which all of our graphs are, your ending value should always be what your period actually is. Right? The period is 3 pi over 2. We started at 0, we did 4 quarters, we got to 3 pi over 2. That's 1 full period. So then we mark the things. Again, your graphs don't have to be to scale, right? 12 pi over 8 is probably, sorry, 12 pi, I wrote 18. I said 8, but I wrote 18. Sorry, it should be 12 pi over 8. Yeah, this is probably, so 12 pi over 8 is a little bit bigger than 4, but this definitely looks a little bit bigger than that 4 there. It's okay. It doesn't have to be precise, super precise. Cosine starts at the top and then goes to the middle. None of our important points should be ending up on the x-axis here, right? They're all either at a height of 1, -1, or -3. And then to the top, middle, then we have to go to the bottom, then back to the middle, then back to the top, then back to the middle, then back to the bottom, then back to the middle, then back to the top, the middle, the bottom, the middle, the top, the middle, right? It just goes on and on. That's why it's called a periodic function. And try your best to graph the graph. It doesn't have to be 100% right. It just has to be close. Like mine looks like it could be a little bit nicer. Sure, perfect. All right. Let's see. Okay, good. We'll get to end like halfway through here. Okay, so let's look at the next one. The next one's not too terrible. One after it's a little bit out there. So the next one is to solve 2 cosine of x plus 1 equal to 0. So typically for a problem like this, you want to isolate. You want to isolate x if you can, but here we're going to isolate cosine x. So I'm going to say 2 cosine x equals -1 and divide both sides by 2. Now, oh, and I should point out, right? This problem says that your answer should be between 0 and 2 pi. At this point, it's not totally wrong to say that x is equal to the inverse cosine of -1/2. But it's not completely right either, because the inverse cosine of -1/2 is, I think we did that before, I think that's 2 pi over 3. But when you're solving an equation, we don't have to be so strict with the number of answers we get. You're allowed to have more than one answer. So it's true that inverse cosine of -1/2 is 2 pi over 3, but that's not really exactly what I want. I really just want the solutions. And the solutions live in quadrant 2, which is 2 pi over 3. But another solution also lives in the other quadrant where cosine is negative, which is quadrant 3, which is 4 pi over 3. So when you're solving an equation like this, you're not bound to the restrictions of an inverse trig function. You can have solutions in any of the 4 quadrants. And the idea is you're supposed to find all the solutions that are possible in all of the quadrants. Okay. So let's see. So the next one is a little bit more challenging. So the next one is cosecant squared of x minus cosecant of x minus 2 is equal to 0. And yeah, this is essentially a quadratic. If you really wanted to, you could do a u substitution. I don't think you have to, but you could go to like u is cosecant of x, and then you could say that this becomes u squared minus u minus 2 equal to 0. And then it factors as u minus 2 times u plus 1. If you do it this way, that's fine. And you get u equal to 2 and u equal to -1. But if you do that, you can't stop there. You have to remember that u is actually cosecant of x. So you have to replace u and say, oh, cosecant of x is equal to 2 and cosecant of x is equal to -1. So if you do a u sub, that's fine. You just have to make sure you finish it and get back to the very u sub. Or you can just factor it, right? You can totally just see that hopefully this factors as cosecant of x minus 2 times cosecant of x plus 1. And then you get the same thing. The cosecant is positive 2, oh sorry, equal to 0. The cosecant is either positive 2 or -1. So now we have to find the solutions. So if I'm solving cosecant of x is equal to 2, that's really not the equation I want to think about. I really want to think about how that's the same as sine of x is equal to 1 over 2. That's how I would think of that. And then sine of x equal to 1/2 in the first and second quadrant. The reference angle is pi over 6. So my answers are pi over 6 in quadrant 1 and 5 pi over 6 in quadrant 2. And then here, cosecant of x is equal to -1. Again, I'm going to think about the reciprocals. The reciprocal of cosecant is sine. The reciprocal of -1 is 1 over -1, which is still -1. So I'm trying to solve sine x equal to -1. And there's actually only one answer. It's the quadrantal angle that's at the, not the top, not the, God, I'm so backwards looking at my, it's not the top, it's not the right, it's the bottom, it's 3 pi over 2. Sorry, I look at myself doing this, I'm like, yeah, I guess it's not the, yeah, bottom, okay. So these are my 3 answers to this equation. Interesting. Let's see, we're almost out of time, but I'll do one more question here because think it does make sense to end with this next question. So the next one is definitely a question that did occur on your first test, like most of these, about inverse trig functions, but I've also thrown in a logarithmic question there as well. So the first one, it says to write out in words what the following means. So inverse sine of root 2 over 2. What this means, it means the angle whose sine is equal to root 2 over 2. That angle is pi over 4. So we could say that inverse sine of root 2 over 2 equals pi over 4. And that'd be enough. I'm going to throw in a because sine of pi over 4 equals root 2 over 2. And then I've asked you kind of the same question for a logarithmic thing. So I also want to talk about the mean. And I know we talked about this yesterday. I'm going to talk about it again. So log base 2 of 8. What does that mean? Well, we know it's the exponent, right? It's the exponent we raise. The same as that's probably sounds weird. It's the exponent we raise 2 to get 8. It's too many 2's. It's the exponent we raise 2 to get 8. It's awful. That's why I usually pick a different base, but oh well. So since 2 to the third is equal to 8, right? That's the exponent that we raise 2 to get 8. Then we know that log base 2 of 8 must equal